Hi everyone. Good evening, good morning, good afternoon, wherever you are from, whichever part of the world you are from. This session is going to be about architecting your app for chaos. The agenda is straightforward. I'll be before going into the agenda, I'll give a brief summary about myself in addition to what Mike had presented. But this is how the agenda goes. So you can decide whether you want to attend the session or not based on this particular agenda. First, I'll be walking you guys through a chaos timeline. Before even introducing chaos to you, I want to take you through the history of why chaos was created, who created chaos, and then how it is currently right now. We will also look at the principles of chaos engineering. What are the different principles which are laid out and how we can benefit from those principles if we follow chaos engineering as a practice. We will also look at the state of chaos in the industry, the different tools which are present in the industry, how we can leverage these tools, what are the different tools for different cloud platforms, what are the bases, are they open source, are they not open source, etc. Right? We will look at all those. And I'll also show some two examples, one with an open source product or one with one particular cloud platform, another one with a multi-cloud platform example, right? So I'll show you how you can leverage these two different tools with an example. And finally, I'll discuss also the challenges of chaos engineering, because there are a lot of different challenges with respect to implementing chaos as a process within your firm, right? So these are the different things which we are going to discuss in this particular session. Just a brief about myself in addition to what Mike had mentioned. I'm Ajay. I live in Chennai. I work at JP Morgan Chase at present. I worked with different financial firms in the past 12 years of my career. So obviously I have broken some stuff in production and I have fixed them and I have learned a lot from them. I just envisioned that if chaos engineering was there when I started my career, I wouldn't have broken many of those stuff which I had broken in the last 12 years, right? I love my job. So this particular presentation is completely mine, and the views and the opinions which I express here, these are all mine, right? Not my employers. If you want to connect with me directly, you can hit about.me/moving to web. That's my social handle. You can go there and then hit me in any of the social platforms which are there right now. With that, let's get started. So just before going into what is chaos, let's look at the whole chaos timeline, right? This particular slide will show the different tools which were created and how they evolved over time, right? So just to give a highlight of who created the whole concept of chaos engineering, Netflix engineering tools team created something called as Chaos Monkey in 2010, right? This was a tool which can go and randomly kill some servers within the cloud platform. Obviously, Netflix used AWS at that point in time, and they did not rely on the cloud as much as they relied on the data centers, right? So they wanted to create a tool which can go and randomly kill servers so that they can understand what's happening to their application, and then they can learn from that particular experiment, right? So that's when Netflix created this tool called Chaos Monkey, and then they open sourced it, right? In 2011, looking at the benefits of the Chaos Monkey as a tool, Netflix created army of tools called a Simian Army. In addition to Chaos Monkey, they created other tools like Chaos Kong, Latency Monkey, and a lot of other failure injection services, which they called it as a Simian Army. Right, this Simian Army is nothing but a collection of different tools which Netflix had it under the umbrella of Simian Army, which they open sourced it in 2011. Yeah. So like I mentioned, Chaos Monkey was open sourced in 2012, right? 2011 is when they created Simian Army. And in 2014, Netflix created a role called Chaos Engineer, right? So this is a completely new thing to the industry, because we have heard of SREs, we have heard of DevOps engineers and things like that. So Netflix created their own role called as Chaos Engineer, right? Which is a completely new thing for the industry, because they leveraged the whole chaos as a concept for the last 4 years, and then they created this new role called chaos engineering, right? In 2016, people who created Chaos Monkey and the whole chaos stuff, they came out of Netflix, and then they created something called as Gremlin. So Gremlin is a product which is a multi-cloud chaos engineering platform, which you can deploy in any cloud platform or use it for on your on-prem data centers, etc. Right? So you can use Gremlin for running chaos experiments. I'll cover that in a bit. But Gremlin is just a tool which was created in 2016. That was the first tool which was coming out of the whole Netflix umbrella, right? Which was the Chaos Monkey. Following that suit, a lot of other products created after this whole Gremlin and the chaos engineering as a concept. Chaos toolkit was one particular library or a toolkit which you can leverage by plugging different drivers for connecting to different cloud platforms or whatever it is. For example, Istio was also started at the same time in 2017, right? Using Istio also, you can control some of these experiments, right? So Chaos Toolkit was one way of controlling different cloud platforms, controlling different infrastructure, right? So Chaos Toolkit was a library, Gremlin was a platform, and it was introduced in 2017. In 2018, there was a dedicated chaos specific conference, which was created called the Chaos Conf by the Gremlin team. This happened in 2018 because looking at the community contribution, chaos emerged as a separate entity. So Gremlin wanted to have a conference dedicated for chaos, right? So that's when Chaos Conference was launched by Gremlin in 2018. Following that suit, the same year, Maya Data, the company, launched an open source product called Litmus. Litmus is now part of the CNCF project. That is another chaos engineering platform. So if you look at all these Gremlin, the Chaos Toolkit, Istio, Litmus, these are similar products, but they solve a specific purpose, which I will cover in the coming slides. Same way, Alibaba being the biggest cloud provider at that particular time, they created their own called as Chaos Blade, which is again Kubernetes specific chaos platform, which they had created. And again, it's open sourced, right? Looking at all these, AWS, being AWS, they created their own well-architected framework. They introduced chaos as a concept inside the well-architected framework in 2020, right? There's also a new chaos mesh, which was created by PingCap. PingCap is the company which created something called as TIDB, which is the Titanium DB, which is a distributed SQL database. They call it the new SQL, if you have not heard of it. So based on that particular project, there was a experiment which emerged for their testing, and that's what Chaos Mesh was. So Chaos Mesh is a Kubernetes native way of running your chaos experiments, which was created by PingCap in 2020. And AWS launched Fault Injection Simulator, and it went GA in 2021. This is the AWS native chaos experiment tool. It is not based on any open source tool or anything. AWS has built their own chaos engineering platform from scratch, right? And that's what Fault Injection Simulator is all about. Right? This is the history of chaos timeline. Now we understood what is the history, but then let's now understand what is chaos, right? In order to understand what is the chaos engineering doing here, right? I mean, we all know what is chaos. Chaos is basically breaking things in production, right? I mean, things getting down all the time. You would have recently heard of Facebook being down, which was one of the most recent failures in the recent times, right? So chaos engineering is a discipline of experimenting a distributed system in order to build confidence in the system's capability to withstand turbulent conditions in production. So I don't want you to summarize or memorize this. We are not going to conduct any exam here, right? So the key things to remember here are the distributed system, because chaos experiments are going to run on distributed systems. This is to build confidence in our system's capability to withstand turbulent conditions in production. So that's the whole goal of chaos engineering as a concept, right? It's all going to be applied on a distributed system, be it cloud or data center, wherever you're working on, you will be having distributed systems. In order to build confidence in your system's capability during turbulent conditions in productions, we are going to perform chaos engineering on those applications. So that's what chaos engineering as a concept is all about, right? Now, behind the scenes of the principle of chaos engineering, there are different principles which we can understand, right? Apart from the whole definition, right? The first thing is to build a steady state of an application. So steady state in the sense, what do I consider as an application to be successful? For example, if I go to facebook.com should be up and running. So that could be a steady state, right? For example, in this particular use case. Now, once the steady state is built, create an hypothesis on what happens if the application goes down and what happens if the application is up. So if the application is up, I'm going to see some Facebook feed of who all has updated, what all is going on within my timeline, right? That's what is the success story. Now, what happens during a failure scenario? Should I show a maintenance kind of a scenario, or should I show the existing message, or should I just say 404 or 500, whatever, right? So that's the hypothesis which you're going to create. So you're going to create a steady state, and then based on that, you're going to say what can go wrong. If something goes wrong, what will be my result? If something is successful, what is my result? So that's the hypothesis which we are going to create. Now, once the hypothesis is created, we are going to design the whole experiment on how to break things, right? Let's say we bring down the whole server. Right? Let's say we hosted facebook.com. We are going to bring down whole facebook.com, or maybe we are going to bring down part of facebook.com and then see how is the behavior, right? For simplicity, let's take an example of, let's say a video streaming service is getting down within the whole facebook.com. Now, how will the response be for the user in terms of this particular failure? So this particular experiment is to kill a particular service which is specific to video streaming service within the facebook.com. Now, how will it look like? Now, from the running the experiments, we will realize that the users are not going to stream the data. They might see some failure messages. Let's say, for instance, the whole page broke and then users were getting redirected to 404, right? I mean, that looks shabby, isn't it? So we can learn those kind of results from what was the experiment's outcome, right? Let's say the facebook.com completely went down, even if only the video streaming service went down, right? In that case, those are the results. And based on those results, we can get some learnings on how the system should behave. Like, let's say if the system went down completely, now next time we need to go and fix the system, saying the whole system shouldn't be going down, but only the video streaming system or the video streaming service should be affected, and only the video shouldn't be playing, right? So this is the whole cycle of how you can use principle of chaos to make your system robust. So I'll just repeat what I said, right? I mean, initially we are going to create a steady state of the system, saying this is how my system behaves during a steady or a successful scenario. I'm going to create a hypothesis saying what happens when there is a successful message, what happens when there is a failure message. And I'm going to experiment run these experiments by creating a design saying, if my server goes down for my video streaming service, what happens to my whole site, right? Based on the outcome, we are going to capture the results of what happened during the experiment. We are going to analyze those results and then fix the system if there are any anomalies which we have detected. So this is the whole concept of principle of chaos. You may ask me, Ajay, this is just looking like another testing, right? I mean, this is not just like a testing, but it is testing with your infrastructure, right? Obviously, this is a test. But if you look at Netflix runs chaos experiments in their production anytime, right? I mean, I don't think everybody is in that kind of a state where we are mature enough to say we can run experiments in production. However, you can treat chaos as a test, but you want to run it in an infrastructure where you're going to deploy it, right? I mean, be it cloud or data center or wherever it is. Now, coming to the failures, right? I mean, what are the different types of failures which we can identify or capture, right? I mean, or maybe introduce so that your systems can break, right? There are a lot of different types of failures, but I'm just giving you some so that you can get a perspective of what are the different types of failures which I mean here, right? The first one is the application level failure. Application level failure could be exceptions, or maybe some particular method written 404, or maybe some particular method written direct exception and you were not able to handle it, so you just threw the exception back, right? Those are different types of application level exceptions or application level failures, right? The next one is host level failure. Though your application was robust, you created 100% robust code, but what happens if your host fails, right? I mean, what happens if the host infrastructure goes for a toss? I mean, somebody rebooted the machine, right? Accidentally, somebody just slipped over a wire and then the whole server went down, right? That could be possible. So that's again a host level failure. The next one is the network level failure. What happens if, let's say, there are regional breakouts or failures in terms of power shortages, right? I mean, we have been hearing about power shortages in the country, in the different parts of the world in the recent times. Now, what happens if there is a regional failure across different data centers when you're hosting some services across data centers, right? I mean, how are we going to handle that? How is our application going to handle it? So you can introduce these kind of failures as well. So this is again another type of failure. And of course, the most popular one is the CPU and the memory level failure, where we most of the time like bombard applications with too much memory or maybe CPU processes, right? I mean, that's another level of failure. So these are different levels of failures which you can inject within the system. Of course, there are different other failures which I don't want to mention here, but just for our reference, I'll be talking about these failures during the course of the next few minutes. Now, what do I get out of running chaos, right? I mean, that's the next question. I mean, already we are running too many things in production. We are running testing, we are running unit tests, we have been running integration tests, we have been running code reviews, we have a lot of pipelines to check so many other things. Why do we even need chaos, right? I mean, what are we going to achieve if we are doing chaos engineering in real world, right? The first one I would say is the safer approach in terms of improving the reliability of the system. one of the most important things which we face these days is how reliable is the system, because we don't know what's happening underneath, because most of the things are abstracted these days, right? And I don't know how is the system going to behave if things go haywire, right? So that's where chaos engineering is going to help predict what's going to happen to our system if something goes wrong, right? And this will be a safer approach because you would have run these experiments prior to prior to what's going to happen in production, right? I mean, maybe some things may not happen in production, but sometimes if it happens, we need to be prepared for what's going to happen and then how the system is going to behave for it, right? I mean, that's what I mean by reliability here. So it's a safer approach to improve reliability of your system because you know things can break and you know how to fix them as well, right? The next one is reducing the mean time to detection. Most of the time what happens is we have failures in productions and it takes a long time to detect what happened, right? Whether the network failure happened, whether the host failed, or whether DNS lookup failed, or whatever it is, right? So using chaos engineering repeatedly, we can identify or reduce the mean time in detecting failures, right? Because if you have been running through failures very often in a day-to-day basis, or maybe whenever we try to deploy into production, we can identify the detection scenarios very easily, right? So the mean time to identify these issues will be reduced. So you can identify issues much faster. The next one is ensuring the monitoring and alerting works as expected. So what do I mean by that is most of the time when we configure alerts, we don't even know whether these alerts will be triggered or not. I have faced these kind of issues real time in the last 10 years, right? I mean, where I have configured some alert, but I don't even know whether this will get triggered or not unless the real scenario hits, right? So what do we try to do? We try to create or simulate some errors, right, to identify those alerts. So that is exactly what chaos is doing. So using chaos engineering, you can identify if the alerting is in place and if the alert works as expected, right? And when something goes wrong, right? I mean, or maybe you could identify if you're getting mail messages via SMS or email messages, or even you can identify if the system is self-healing, right? I mean, let's say I go and kill some particular pod if you're running in Kubernetes. Now you can identify whether Kubernetes is immediately bringing that pod up or not, and then the alert got triggered or not. Because one thing is the system self-healing itself. The other thing is you getting alerted that something broke and then it got fixed, right? So that's where you can leverage monitoring and alerting to identify if the chaos, if your application behaved well when something went wrong, right? The next, obviously, the important thing is your SREs should be aware of what's happening, right? I think most of the time what happens when there is a failure in production, SREs have no clue on what failed, right? Because they are not even prepped for it, right? That's where we will have to go from, again, from the square one, right? To identify what happened in each phase of your application journey, right? So when you're running chaos engineering or chaos experiments very often in your production infrastructure, you can leverage possible failures, and SREs would be prepared to handle those failures. And they would know that, okay, this particular alert came because something failed. Now I went and saw that the system got fixed by itself, right? Because this is self-healing, right? So that's how SREs will be able to understand how the systems are behaving, right? And they don't bug you when you're coding, right? So that's another advantage. The next one would be continuously validating your reliability, right? So one thing is saying that I have run chaos experiments once in a while. The other thing is saying that I continuously run these experiments and validate my system's behavior. So that way I have reliable infrastructure or reliable application which is running. Even if my infrastructure goes down, I'm still able to recover my application or fix my application whenever there is unreliability, right? So you should leverage CI/CDs to automate your infrastructure or your chaos experiments on your infrastructure. So that way you can continuously validate your reliability of your application. And the final thing is obviously reusing some experiments across your firm or your company or your applications so that you can have common patterns and you don't have to reinvent the wheel, right? I think once you have an exhaustive list of patterns created, you can easily leverage these patterns to run these experiments. And with the community contribution these days with open source, you know how much powerful community contributions are. You can leverage the existing chaos experiments and run them in your infrastructure and then identify what are the issues in your application and then go and fix them, right? You can do the same principles of chaos and then just run these experiments and then make your application more reliable. So these are the different benefits of chaos engineering. And that's why we are even talking about introducing chaos inside an architectural aspect, right? Now, what's happening in the industry, right? Now that we understood what is chaos experiment, what is chaos engineering, right? Now, what is happening in the industry? What are the different tools which are available? Obviously, there are a lot of tools. You can see that there could be even more. I have just collected the most popular ones, right? So Chaos Mesh is again specific to Kubernetes, right? So Chaos Mesh is a chaos engineering platform using which you can run chaos experiments on Kubernetes. It's an open source product. Like I said, it came out of PingCap, which was a company which created TIDB. So this product came out of that. Chaos Blade is again a Kubernetes native open source product by Alibaba, right? Which is again under CNCF right now. This particular project is also under CNCF. Gremlin is not an open source product, but it's a SaaS, right? So Gremlin is a SaaS using which you can run chaos experiments, right? It's one of the first chaos experimenting platform, right? I mean, it's one of the first chaos engineering platform which was created, right? So it is much more mature, I would say, than the other platforms, because I have used Gremlin a lot. SteadyBit is another vulnerability identification system, but it also does chaos injection, right? I mean, it is not an open source product, but it also does vulnerability detection in terms of security issues in your Kubernetes cluster, but it also can do chaos engineering on your Flux. Chaos Cube, as the name suggests, it is again Kubernetes native, right? Again, it's an open source product, which is specific for Kubernetes. Chaos, it's again a platform, right? Chaos Toolkit is not a platform. Chaos Toolkit is a library or a toolkit, like it's mentioned. You can use it with other products. You can use it within your Spring Boot application, etc. And then you can plug it with different drivers which are specific to those cloud platforms. And it's completely open source. So there are different open source drivers which are available out there, which you can leverage, right? Litmus is another popular chaos engineering platform, again, which is open source, which is under CNCF. There are a lot of different open source platforms. A majority of them support some specific use cases, but then majority of them can be used for multiple clouds or even on-prem systems, right? For example, Gremlin can be run on premise, it can be run on any cloud platform, etc. Right? You can even run Gremlin on serverless, right? I'll talk about Gremlin in a bit. And finally, we have AWS coming into the league. AWS has something called Fault Injection Simulator. This was one of the newest service which was launched last year in their reinvent. From this year, it went GA. Fault Injection Simulator is another service which is AWS native, and you can leverage injecting chaos experiments or faults basically into some of these AWS services, and you can identify the behavior of your system using this particular service in AWS, right? Obviously, Gremlin, SteadyBit, and AWS Fault Injection Service Simulator are not open source. The rest of them are open sourced, right? So this is the state of the chaos in the industry. A lot of companies use a lot of products. For example, Litmus is used by Intuit, Red Hat, VMware, and most of these companies, right? I mean, that's this particular product, right? Gremlin is again used by a lot of other companies. I mean, most of the enterprises are using Gremlin because it's one of the most mature products, but a lot of open source specific companies use Litmus, right? And recently with AWS Fault Injection Simulator, people are trying to explore AWS as well, right? Because it's natively integrated with AWS. Going to the next slide. Like I mentioned, I wanted to explain two different examples, right? I mean, on how can I run experiments on, or how will my architecture look like if I, let's say, use Gremlin, right? For example, the first experiment is about, example is about Gremlin. Now let's look at the architecture. How would it look like, right? Imagine I'm going to use AWS, replace AWS with data center or Azure or Google Cloud, whichever it is, it will work in the same fashion. I'm just using AWS as a reference here. So within an AWS account, I have a VPC, I have a public subnet, which is like your boundary, right? Now within that, I have an EC2 instance. This is just like a bare metal machine, which I have. I have my application running in there. Now I want to run some experiments on this particular application, right? Now I don't have to do any application level code change. Instead, I will have to introduce, right, some infrastructure level changes. For example, if I'm using Gremlin, Gremlin is a SaaS product, so I don't have to run Gremlin within my infrastructure, but I would want to have an agent which is going to interact with my Gremlin SaaS, right? So the Gremlin agent is going to run within your EC2 instance, which can talk to the Gremlin SaaS instance, and it can interact on what needs to be done, etc. So Gremlin engineering, the Gremlin SaaS, which is the chaos engineering platform, has an intuitive UI using which you can trigger experiments. You can schedule experiments, you can configure experiments. There are a lot of reusable experiments, and you can even create some of your own experiments from the Gremlin console, right? So from there, you can trigger these experiments, and the agent will be like triggering those commands, whatever you have been mentioning via the console, right? So this is how Gremlin works, right? Now, considering it for a serverless kind of an application, now how does this work, right? Gremlin has a concept of application level fault injection. If you remember the application level failure, which I mentioned earlier, where we can have failures happening at the method level or maybe at the request level, you can introduce failures even for an API level within a process, or maybe at the request level. You can introduce latency for one specific request. You can introduce failures for one particular method, etc. You can do that. And also you can inject failures or faults in a serverless construct using the application level fault injection from Gremlin, right? So Gremlin is one of the most mature ones. So they do have ALFI. ALFI is nothing but the application level fault injection, which can run chaos experiments for your serverless workloads. So that's about Gremlin. Now let's look at one of the newest one. So I just wanted to pick one of the oldest one and one of the newest one. So that way we can compare and contrast with these examples. So I'm picking up the AWS fault injection simulator, which is the newest one. Now this works slightly in a different fashion because AWS FIS is a native service which is introduced by AWS. So obviously AWS has a lot of control over what's happening within their infrastructure. And of course, you cannot use this inside other cloud platforms right now, but you can use it only within AWS. So I have the same architecture. In this case, I'm going to run FIS within a EKS cluster. So this is a Kubernetes cluster, which is managed by Amazon. So I don't have any control plane deployed, but I do have my data plane where I am running my pods, right? I do have a lot of applications which are leveraging Istio, right? If you don't know what is Istio, Istio is a service mesh using which you can integrate with different microservices. So like I mentioned, this is a distributed system. So I have multiple microservices within my architecture. So I have Istio within my Kubernetes cluster. Now this itself is a complicated architecture. Now, how do I run FIS? We don't have to do any code change to the cluster because the only thing the fault injection simulator needs is the roles and the tokens. So that way it can go and kill some things or introduce latency, create some black holes, shut down some servers, right, etc. So fault injection simulator is like a chaos engineering platform within AWS, but it is not exposed outside. You can use, again, this is similar to Gremlin, like how you have a SaaS, but the only difference is Amazon controls the whole managed SaaS. So this is like a managed service, right? Like how we have managed EKS, fault injection simulator is also a managed chaos platform using which you can run these experiments. You can schedule these experiments, etc. One interesting thing which Gremlin couldn't do, which fault injection simulator can do, is introducing automatic failovers when there are database failures. For example, we have an RDS instance running in AWS. Now, how does an application behave if the master goes down and the slave comes in and then kicks in? Now, what happens is there is a 30 seconds delay because when the master goes down, Amazon has to identify that, okay, there is a master which is going down. So I need to make my slave as the master, right? In that case, what happens is there will be a 30-second delay, right? In terms of flipping the instance from primary to secondary, right? So in that case, how do our application behave, right? Now, it's very difficult to simulate this particular scenario in production or in your environment. So this is where fault injection simulator is going to help us. It can do this out of the box, right? Which Gremlin couldn't do right now, but fault injection simulator can immediately flip from your primary to secondary, and you can easily identify what's happening to your application during this particular journey, right? So this is where FIS is currently. FIS is not mature enough to compete with Gremlin. That's what I would say. However, it has a lot of other benefits. If you're using AWS native cloud platform, then FIS is a good choice because it's coming out of the box and the configuration which you have to do is very minimal compared to the other products, right? So those are the different examples which I wanted to show. The final thing is I want to show you some of the different challenges which we go through, right? I mean, one thing is just learning these new technologies, right? I mean, learning all these new technologies just for the fashion. You can tell people that, oh yeah, I know what is chaos engineering, etc., and things like that. The other thing is adopting these challenges or adopting these technologies, right? I mean, and there are a lot of challenges when you adopt these, right? The first one would be the culture, right? So that's where we all lag behind, right? I mean, though too many products come in the industry, it's very difficult to convince people to say we should follow it, right? Same way, the culture of breaking and fixing things is tough, right? Because if something breaks in production, we always go about fixing them, right? But however, running these as a frequent thing is a culture, right? I mean, when DevOps was created or DevOps processes evolved, it was difficult for companies to go into that kind of culture, right? I mean, same way, chaos is also a culture where you will have to practice breaking things and then fixing things, or else it's going to be a tedious process, right? So the first challenge which we face in the whole implementation of chaos engineering is the culture. The next one is no time to test, right? I think we already are running so many tests. We already are running pipelines which are running for hours and hours, and then we want to run one more test, right? I mean, that's another challenge to convince people that, okay, this is another experiment. You need to run another test suite kind of a thing to understand how your system behaves, right? Which is another challenge. The other thing is understanding the technical implementation details of your system when there is a failure, right? Because it's not like you just kill your system, kill your application, and then just identify what's the issue. No, it's not. You need to understand the technical implementation, because sometimes when you handle some failures, there could be something which can go wrong, right? I mean, you might be calling a secondary URL when primary goes down and things like that, right? In that case, you will have to know the technical implementation details, or else you will be burning your hands. So you need to have a technical understanding of your failure implementation or your failure handling in order to do chaos engineering. And finally, like, not all applications have the luxury of experimenting new things, right? I mean, most of the applications are critical and there is a cost in terms of maintaining them, right? I mean, for example, if let's say I have a small application where there is no cost of maintenance, I mean, even if something fails, nobody's going to be bothered about it, right? In that case, it doesn't make sense to run chaos experiments, right? So there is a way you need to identify if you're running chaos, right? I mean, is it worth it for that particular application, right? I mean, is it necessary for a critical application, or is it necessary for a non-critical application? So those are the different challenges which are specific to the chaos engineering platform or the principles, right? So those are the different things which I wanted to cover. I think I've covered pretty much whatever I wanted to. I would like to hear from you on what are your thoughts? What do you think? If you have any questions, do raise your hand. So I think I can unmute you if you guys are ready to speak up. If you are shy, you can just post your question in the chat section. I'm okay to pick up your question from there as well. Right. Meanwhile, you can reach out to me in this particular handle. You can go to about.me/moving to web. Right. If you're still shy asking some things from here, you can go ahead and ask me privately after the session as well. Right. Cool. Any questions? Anybody wants to raise your hands? Or just post it in the chat section. I mean, I'm okay picking up your questions from the Q&A as well. No questions?
If there aren't any questions, feel free to use the rest of the time however you wish. We have until 11:30 for this session, and then the next talk will be starting at 11:45. We have 2 items in the chat window.
Oh, okay. Let me check. Hi, Kyle. Yep, thanks for the question. So what are some common mitigation strategies for something like a single large application that is business critical? Yeah, awesome question. Thanks for asking that, Kat. This is one of the common things which we go through, right? I mean, we have a monolithic application, but then it's very critical. Now, what kind of mitigation strategy should I follow, right? I mean, one thing obviously is you should have multiple instances of the application running. I mean, that's the common thing which everybody wants, right? I mean, let's say these kind of failures happen, and these are specific, right? For example, if there is a host level failure, then it would fit into this scalability option where you have multiple instances of your application, and it is okay to do that, right? The other thing is what happens if there is a failure which is application specific, right? I mean, or a request specific. In that case, it's very difficult to handle it, during the runtime. Obviously, you will have to look at your application code and then fix them, but you can run these kind of experiments in your UAT environment. You don't have to run these in production. That's the beauty about the whole chaos engineering, right? I mean, nobody is forcing you to run chaos experiments in production, but you can run them in your test environment or even in your dev environment. That way you can create confidence in your system, and then you can create scenarios saying, okay, this is how my system behaves, and you can document them, right? And you don't even have to run these in production. So Netflix is crazy because Netflix has such a mature system. They have been running chaos experiments for the last few years. So they run these experiments in production. But for us, I would say we should just run it in dev first and then get our systems comfortable and then move it to prod. Most of the time when we create a new feature, we are even like afraid to run it in production, right? I mean, that's what all developers go through, right? So I would say run these in test or UAT, right? Though it is business critical, you can run these in your test environment, and then you can identify the results, and then you will be able to understand. You can sit together as a team and then see what to do when something breaks, right? I mean, maybe you can fix it in a matter of few seconds, or maybe the system could automatically fix it, or maybe you need a code fix to do that, right? I mean, it depends, right? So that way you can run these in your QA non-prod environment and then understand your behavior of the system and then go about fixing it, right? I hope that was helpful. The next question is from Amrit Sagar. Thanks, Ajay. This was good. Thank you very much, Amrit. Thanks for commenting. What tool do you recommend, like in Kubernetes space? As you mentioned, multiple in the section. Yeah. So there are a lot of different tools. The first thing, obviously, I would say is whichever tool your company asks you to work on that. But my choice of preference, right? I mean, if you see the session, if you see these tools, right? I have used Gremlin. I have used Chaos Toolkit. I wanted to use Litmus. I have used AWS Fault Injection Simulator as well. If you're right now starting off with Chaos, and if you're already using AWS, it's easier to do AWS Fault Injection Simulator than doing other products, right? I mean, you will spend a lot of time in terms of researching, looking at the documentation, etc. But if you're already using AWS, you can definitely use FIS and then understand how things work, right? I mean, understand the whole concept of chaos, right? Then you can jump into some of the open source. If you're using Kubernetes, then definitely look at Litmus first, right? And then you can explore, let's say Litmus was too much for you, or maybe Litmus is not giving some features, then you can look at Gremlin, right? Gremlin is an enterprise product. You won't get a free version of it, but you can still try out some free stuff, right? I mean, I have tried Gremlin outside and inside as well. I mean, I have tried both enterprise version and the community version. It is an amazing product, right? I think I like Gremlin for their UI and the intuitiveness, right? But it's up to you. My personal choice would be if you're using AWS, go with FIS first and then try out, and then go with Gremlin, right? Gremlin is more mature, and then if time permits, do the Litmus as well. That's my view. Thank you for asking the question, Amrit. Garrett, hi Garrett. Would it be good to do this in test environment if taking down product? Yeah, that I think I just mentioned it a few minutes ago, right? I mean, I wouldn't advise you to run it in production unless your products are much more mature and you're okay to run these in production, right? I mean, I think it makes sense to run it in test, because even in test, if something goes wrong, I mean, you might be getting a call to fix it because there could be some other team which is running your test infrastructure or test APIs, right? I mean, you may want to fix that quickly, right? So test itself is a good production-like scenario. So you can run these experiments in test and you can proceed to production once you think that this can be run in production. Right? And even in production, you can take a step-by-step approach, right? For example, you can run a scheduled chaos experiment. Like I mentioned, you can run it as a part of a CI/CD pipeline, or maybe you can run it as a part of a scheduled job, which happens only during weekends, or maybe it happens during low volume times, etc. Right? I mean, that way you can still validate your reliability of your infrastructure in production, but you still restrict that to a specific time limit or a specific set of users, right? That way you don't disturb the whole system if something goes haywire, right? I mean, so that's how you can approach, right? I mean, it's up to you how your system is mature enough to handle these failures, right? But just get started. I mean, try running these in dev, right? I mean, I found out so many bugs in my application when I started running these in dev, right? That way I was able to understand, okay, these are not there, these are not for my system, these are not required, these are maintenance headache, these are required, etc. Right? So that way you will have an understanding of how you can run this. It's not like, see, if you look at chaos engineering, it's not something new which we invented, but it's a way of automatically running these experiments as a part of your SDLC cycle or your end-to-end journey, right? Earlier, we used to just react to these whenever things go bad, but now you have a way to run these real time. So that way you can understand the system and then fix your system whenever you require it. right? So that's what I see chaos as. If you don't need to use chaos in your product, it's totally fine, right? I mean, like I said, the challenges or the whatever, right? I mean, if your product is very small, you don't need that kind of reliability in your system, it's totally okay. But yeah, just get to know what is chaos, because it's completely new, and a lot of people are trying to use chaos to create reliable systems, right? In the cloud and also in the data centers, right? Like Kyle asked, you can even run chaos experiments on your monolithic applications. You can search for application level fault injection if you guys are not aware of. That's a way to introduce failures for a particular method, right? It's something like introducing exception during a unit test, right? It's something like that, but it does real time when your application is running, right? Which is a fancy thing, right? You can introduce latencies. For example, let's say you have an API. It returns the response of a particular API within like few milliseconds, but you can introduce latency saying 30 milliseconds or 1 minute and see how your application behaves, right? I mean, your UI should not froze, your UI should break the call or something like that. I mean, you can validate all these kind of scenarios as a part of the whole chaos experiment strategy, right? Cool. Thank you very much, guys. Thanks for asking the questions. Those are very helpful for others, I believe. I hope you guys enjoyed the session. If you have any other questions, you can just pop up in the chat. If not, I think enjoy the rest of the day, enjoy the rest of the sessions in All Things Open. I think I have the next question. Hey, Sanjay, how are you? How frequently are these experiments done by big companies? It depends, right? I think I cannot like say, I mean, in general for big companies, right? I mean, it's up to you. Like I mentioned, you can run it as a scheduled job, right? Maybe you can run it weekly, right? Or maybe you can run it as a maintenance schedule, right? Some companies have a maintenance schedule of, let's say, 1 week or 2 weeks or 3 weeks or a monthly cycle, right? You can run these as a part of your maintenance schedule, right? Usually there used to be a process called as business continuity process. If you guys have gone through that, something like you have a product running in production, you just bring those down and then you run it in your disaster recovery zone, and then you check the validity of the application, right? Imagine that being done real time, right? That's what chaos is all about. So you can run chaos experiments as a part of your business continuity process, right? So you can do that anytime. So I would suggest maybe run once in every month, right? If you're like too much concerned about, right, identifying issues, if let's say you're pushing code very often into production, right, and you're changing infrastructure a lot, then run it once in a week or once in 2 weeks, right? I mean, and then record these results and then identify what's happening to your application. If something breaks, obviously you have to fix it, right? I mean, so you need to be prepared. So if you're running it in your test environment, you should definitely run it every now and then, right? I would say at least monthly cycle should be good enough, right? Or if you're doing an agile kind of a cycle, you should run it every 2 weeks or 1 week or maybe 3 weeks, whichever is your sprint cycle, right? So I would suggest that. Yeah, cool. Thank you, Sanjay, for joining and asking questions.